Hello again. Um, so we've been learning about bacteria and what they do the last couple times. Now, today and tomorrow, I want to talk about specific bacterial infections, kind of like what we did with the viruses. I find this part to be more interesting in the actual specifics of the bacteria and what they can do. One word of caution, though: viewer discretion is advised. I did hold back. And there's like one photo in here, maybe two, a little not absurdly graphic, but I did hold back. There are a lot of photos that I'd like to put on, but I did not. Let's keep that in mind. I'll try to remember to warn you on that one photo that I found. If you don't like intestines, you might not want to look at that photo. All right, the first one is tetanus, and it's a gram-positive rod bacilli. It's a Clostridium tetani. It's anaerobic, and it produces a neurotoxin. And tetanus, being anaerobic, you may remember, you may have been told, right? It's that rusty nail where you get that puncture wound that does not that heals over quickly, blocking in the bacteria. So you have a little bit of bacteria in that puncture wound, and then it gets sealed into the wound, and it's held off to the atmosphere, and the oxygen can get in, and it'll thrive in that kind of environment if the skin encloses around the wound. Hydrogen peroxide is good as an initial method. It'll oxygenate that wound. It's also pretty toxic itself, but hydrogen peroxide on a wound will be helpful. Tetanus, you don't hear about it too much anymore because we're vaccinated for it, but it produces a neurotoxin. And that neurotoxin can cause muscle spasms. And this is and I was looking at a video earlier about tetanus, but this is a painting of a person who's affected by tetanus, and the muscle spasms can happen so bad that you actually break your back, right? So people will clench their muscles, and it'll force them up into such a way that they arch their back and they can crack their back. There's a name for this, which I don't know off the top of my head. Kudos to you if you want to look that up. But ultimately, these muscle spasms are going to cause, it's basically muscles contracting, constant contraction of the muscles, which leads to paralysis and lockjaw. It's one of the first symptoms of it. And this is some of the pictures that I withheld. Your face kind of crunches up into this weird looking smile, and you can't move your jaw, and you can't move your mouth. And I've heard that at that point, although I bet you modern medicine's a little bit better now, but once that neurotoxin starts and you have the symptoms of lockjaw, that it's a race between the toxin and the bacteria. You can give antibiotics, but if that toxin's still there, you're still going to have the muscle spasms, the paralysis. And this paralysis will ultimately lead, if you don't break your back first, will ultimately lead to asphyxiation. So your muscles clench all over your body. It's like having a giant muscle spasm. If you've ever had kind of like a Charlie horse, or just the muscle clench, but having that over your entire body does not sound like fun. And ultimately, the death would be through asphyxiation. Yeah, I thought so. But that's tetanus. Okay, we don't have to worry about it. It's pretty much it's all over the place, but we're vaccinated against it. So keep your vaccinations up, and you don't have to worry about breaking your back because of bacteria. The next one, botulism, also a Clostridium bacteria, gram-positive rod. So it would be that purple color under the microscope. Also anaerobic. Botulism is also a neurotoxin that causes paralysis, but whereas tetanus causes your muscles to be in a constant state of contraction and clenching. See about this person. Botulism has the opposite effect. It actually causes your muscles to stop contracting. So you become very lethargic, and your muscles don't work, and it causes paralysis in the opposite fashion of botulism. Botulism has an endospore that it forms. It's pretty hardy. And so I think I heard this story from a professor in college, but you can have rice, right? And the syndospore can be on rice, and you'll cook your rice, and it will, the uncooked rice is kind of dry, and the spore's there. When you cook it, it'll survive the boiling of the rice, and now you've given it a food source by hydrating the rice, and then it'll allow it to grow a little bit. So you leave that food out over time, and it can grow. And also the canned goods. There was an outbreak of botulism in the 80s, and it was in canned food. And the only symptom of the food was these deformed cans, because this botulism was forming gas inside, and you get these bubbled cans. So you can get, there are many different types of botulism. I want to focus on two different types here. The foodborne, right, somewhat on rice, and then the improperly sealed canned goods, which was a problem. I don't know that it's much of a problem anymore. I don't hear a huge amount about botulism and death through botulism. But infant botulism, which is not nearly as fatal as the foodborne one, causes the infant to be lethargic. You can see this picture here. The baby's pretty much just like just laying here. And you're not actually supposed to give newborns honey. And one of the reasons why is this honey can contain this spore that really only affects the little kids, infants, and whatnot. So for us, it's fine, but it can cause problems in infants. The other place you're going to see botulism nowadays is through cosmetic surgery. People will inject the botulism toxin into their skin to paralyze portions of their face to, it helps get rid of wrinkles or something. But people have had complications from this, so it's not, anytime you're injecting yourself with a toxin, it's probably not necessarily a wise idea. But, hey, maybe I'll be fighting wrinkles someday and decide that botulism toxin isn't a necessity. Who knows? All right. Cholera. Vibrio cholera. I misspoke last time. I always thought it was a spiral-shaped one, but no, it's a rod-shaped as well. It's gram-negative, not gram-dash. This is an interesting guy. It's an intestinal bacteria. Yeah, that's a picture of cholera. And you can see that it's got a nice long flagellum. And what will happen is you ingest cholera through infected water or food, mainly through water. And this toxin that is there causes the cells to release fluid into the intestines. And this mechanism is pretty interesting. The toxin will enter the cell, gets kind of the cell and the intestines will take it up, and once it's in there, it causes kind of a chain reaction. There's multi-steps to this, but the ultimate step is the release of fluid into the intestines. And if you are squeamish on intestinal pictures of, I think it's a sheep, then you might want to pause or try to skip ahead, because here's the picture I was warning you about. So this fluid, right, can cause massive diarrhea, right, and up to 2 liters per hour of fluid can be flowing out of your intestines. And here's a photo. This first one here has been infected with cholera, and the second one has not been. So you can see the picture C and D. So picture C, you see this very enlarged intestine, or in D, it's just kind of normal size. This has all been filled with fluid because of the cholera cell. It has a second toxin. There's 2 types. One that will cause the fluid to be released. The other one actually helps it attach to the intestinal cell, the cells in the intestine. And it has a couple mechanisms. So you get these cholera bacteria accumulating in the intestines, and they're fighting for resources. But once you hit a critical limit, the cholera bacteria start producing a substance, I believe it's a protein, that will stop additional bacteria cells from attaching to the intestines. And those bacteria cells then get released with the fluid back into the, potentially back into the water supply, wherever you're doing your diarrhea. So this can be a problem in areas that don't have good water sources. You're running and you're doing your business, and it gets back into the water supply, and then everyone starts drinking out of that water, and everyone's getting cholera, and it's just one big diarrhea fest, I suppose. But the big problem with cholera is dehydration. If you're losing 2 liters of water an hour, it's not going to be long before you're dehydrated and die. And dehydration and diarrheal diseases used to be the #1 cause of death in the world up until a number of years ago. But it's an interesting little guy. Again, we don't have issues with cholera in the United States, but if you ever go overseas, you may you got to watch out for some of these bacterial diseases. And it's I can't imagine it being very fun. Limiting 2 liters of fluid an hour. All right, I'm going a little long, and maybe I should, I'm talking a little fast too, but I wanted to do one more. There are so many bacteria that we could talk about. Maybe I'll have let's plan 2 days, maybe 3 days. But E. coli. E. coli is a gram-negative rod, bacilli, and really, E. coli is one of the most common bacteria cells in our bodies. Right, it's everywhere. And what is the problem is this particular E. coli 0157H7, which is a facultative anaerobe, but it's a toxin that is the problem. Most E. coli are fine. It's this particular E. coli that gives all E. coli a bad name, and it's from a plasmid, the 0157 plasmid, hence the name. And that toxin is a Shiga toxin, which causes the breakdown of the ribosomes within cells. So once those ribosomes have been broken down, they can no longer make proteins. They end up dying, and those cells that are acted upon are usually lining blood vessels. Right, that causes bloody diarrhea, another diarrheal disease. Massive bloody diarrhea sometimes, and if left untreated, E. coli can lead to hemolytic uremic syndrome, where the kidneys are shutting down. You don't have, you're losing platelets and blood, and it's not a good situation. I believe this can form 10 days after the initial infection. But E. coli and this toxin, I think the theory is that cows are immune to the toxin. That the toxin can't actually enter their cells, so they can kind of harbor this bacteria without being infected, or affected, I should say, affected by it. And then they do their business out in the fields, and it ends up on our vegetables. You don't wash your vegetables, and then it's the old fecal-oral route of transmission, same as cholera. Also, if the cows have it, that's why we cook the meat to a certain temperature. You want to kill any bacteria, and every now and then you'll hear about an E. coli outbreak. If treated, it's not usually fatal, and with all of these diseases, really, if they're treated, it's not really fatal. It's catching it in time. That's all I have. I talked kind of fast. I probably forgot some things, but I got more for you tomorrow. I got necrotizing fasciitis tomorrow. It's another fun one. There's some great photos, so be forewarned. Enjoy your day. Don't forget to subscribe. I need 1,000 subscribers.